Hello students, so this is lecture number 4 of electric charge and electric field, right? At the previous lecture we had discussed about Coulomb's law, that is the force between two stationary point charges. We had also seen what do you mean by point charge, what is epsilon naught, what is the meaning of electrical permittivity, right? Now we'll understand that how Coulomb's law gets affected, or rather speaking how the force between two charges gets affected in the presence of medium. That means, see, we had discussed in the last video that whenever two stationary point charges when placed at a distance r from each other, right, the force between these charges will be 1 upon 4 pi epsilon naught q1 q2 by r square. Epsilon naught is known as electrical permittivity of free space or vacuum, right? And I have made it very clear that what is the meaning of epsilon naught. Clear? It is a property of the medium to absorb the electric field. Clear? Okay, so this is the force between two charges when the charges are placed in air. The force between two charges depends on the medium. See, epsilon naught means it is electrical permittivity. That is a property of the medium. So the force between two charges depends on the medium. So now if I am changing the medium, or if I am placing both the charges in any another medium, the force between two charges will also change. Clear? Suppose I am placing both the charges in any medium, say water, oil, kerosene, anything, right? So now when the charges are placed in the medium, so the force between two charges will be 1 upon 4 pi epsilon q1 q2 by r square. Now epsilon represents permittivity of the medium, in which both the charges are placed. Suppose let us take that charges are placed in the medium of glass. So epsilon will represent the permittivity of the medium, glass. So now let us compare the force when both the charges were placed in air and the force when both the charges are placed in any medium. So let us divide this to equation. Electrical force, this. So it will be 1 upon 4 pi, everything gets cancelled, epsilon by epsilon naught, right? So force in vacuum, or force between two charges in air upon force between two charges in medium, is equals to epsilon by epsilon naught. That is permittivity of medium upon permittivity of vacuum. This is known as relative permittivity. Relative permittivity means permittivity of medium with respect to vacuum, right? That is known as relative permittivity, or also known as dielectric constant. K is known as dielectric constant. Dielectric means insulator. K is also known as specific inductive capacity. This is other name of dielectric constant, SIC, specific inductive capacity. Clear? Right? So finally, force between two charges placed in vacuum in air upon force between two charges placed in medium is equals to K. This equation can be rewritten as force between two charges in a medium is equals to force between two charges when placed in vacuum upon K. Right? It means that whenever you are placing the charge from air to any another medium, force between two charges decreases by factor K. Clear? The value of K is different for different material, different medium. Like suppose we can say that K is 1 for vacuum. Vacuum means empty space, nothing. K is 1.0003 for air. You can take the value for air or vacuum or free space equals to 1, there is no problem, right? The value of K is infinite for pure metal, The value of K is greater than 1 for insulator, right? So these are the values of K. K is known as dielectric constant or a specific inductive capacity. Okay, so the thing that is to be marked as important is the force between two charges when placed in a medium, right, will decrease by a factor K, where K is known as any dielectric constant, and the values of K for different medium are given. Clear? So the effect of medium is that the force between two charges will decrease when the charges are being placed into any another medium from air or vacuum, right? See, we'll say that suppose the force between two charges placed in air at a particular distance d is alpha, right? The Coulombian force between two charges placed in air at a particular distance d is alpha. Now the charges are taken into a medium of dielectric constant K. The value is not specified, K. Now the force between two charges for same separation will be, the question is very easy. The force between two charges when placed in air at a particular distance d is alpha, right? So the force, suppose these are two charges, right, they are placed in air, the distance between them is d, so the force is alpha, so alpha will be k q and q2 by r square. Instead of f we are writing as k, or I will write this as 1 by 4 pi epsilon naught q and q2 by r square. Now you are placing this charges into a medium of dielectric constant. Now I am taking this charges into a medium of dielectric constant K. So now the force will be F dash will be 1 upon 4 pi epsilon q1 q2 by r square. Right? I can directly say that whenever you are taking the charges into any other medium, force will reduce by a factor K. So your force will be alpha by K. It's okay, but now let us divide this equation. F dash by alpha equals to epsilon naught by epsilon. So f dash by alpha is equals to, this will be 1 by k, so f dash will be alpha by k. Clear? So force will decrease by factor k. Right? See. Let us say that two charges q1 and q2, the distance between them is r, right? The force between them is say Fe. Now I am placing them in a copper sheet. So the medium is copper. So what will be the new force now? So now the new force will be Fe by K. Copper is a metal, and for metal value of K is infinite. So force between two charges is 0. See, one point. I am giving you one more formula. You should not be confused between this formula and the formula which I am giving you now. If between two charges, let us say the distance between, means there are two charges, let R be the separation between two charges. Now suppose I am placing a medium, of thickness T and dielectric constant K. Now this case is different from this case. In this case we are placing the charges in the medium, and this is a case where between two charges you have placed a medium. Done? So let us say this as case 1. In case 1 we have just placed both the charges in a particular medium, and the formula of the force between two charges will be Fe by K. But here the formula will be 1 upon 4 pi epsilon naught Q1 Q2 upon R minus T plus T root K the whole square. Of course we will derive this formula, but on the temporary basis just remember this formula. K Q1 Q2 upon R means the separation, minus T is the thickness of the slab, thickness of the medium which you have placed between the two charges, plus T root K, where K represents the dielectric constant, right? See, these two cases are different, don't get confused. In the case 1 you are placing both the charges in a medium, and this is the case where between two charges a medium is placed. Clear? So up till now we have discussed about Coulomb's law and what are the effect of the medium on Coulomb's law or the forces between two charges. Now we will solve the questions based on these formulas in the next video.